In our lesson today, we're going to look at graphs of proportional relationships. Last class, we learned that when two quantities are proportional, they have a constant ratio, better known as the constant of proportionality, which we use the variable k to represent. This can be shown in a variety of ways, including in tables and in graphs. In our first example, they tell us that the relationship between the total weight and the number of boxes is proportional. 6 boxes weigh 12 pounds. Okay, so we already know that we're working with a proportional relationship, and we know that 6 boxes weigh 12 pounds. We should figure out what the unit rate is for this example. And the way that we would do this, we would want to know the pounds per box. All right, so let's set this up as pounds per box. All right, they say that 6 boxes weigh 12 pounds. So my ratio is going to be 12 to 6. All right, it's 12 pounds for 6 boxes. We want to know the unit rate. How many pounds is it for just one box? So we would divide each number by 6 in order to scale back to the unit rate. 12 divided by 6 is equal to 2. Okay, so I now know that the unit rate is 2 pounds per box. Okay, 2 pounds per box. So using this information, I'm going to complete my table. All right, now no boxes have no weight. That makes sense. 2 boxes, how many pounds would that be? Well, if it's 2 pounds for each box and we have 2 boxes, 2 times 2, that's going to equal 4 pounds. 4 boxes would have to weigh 8 pounds. 4 times 2 is 8. They already told us that 6 boxes weigh 12 pounds, and 8 boxes would have to weigh 16 pounds. Okay. Again, the constant unit rate, we've already defined that up here. That was 2 pounds per box. Okay, since that's our unit rate, 2 pounds per box, our value of k would be either 2 or 2 over 1. Again, that's your constant of proportionality, which does not include units. 2 or 2 over 1 is the value of k. And again, the ratio of the number of boxes to total weight shows a proportional relationship. Okay, so this is very similar to what we did in our last lesson. Okay, for the new part, we're going to take this information and we're going to have to graph it on the graph that we see at the bottom of the page. Before we do that, though, there are a couple of things that we have to figure out. In this relationship, there is an independent variable and there is a dependent variable. Think about this example. Does the total weight depend upon the number of boxes, or does the number of boxes depend on the total weight? Which one causes the other to change? Okay, well, in this example, the weight gets changed each time that you add a box. Okay, so that means that the total weight depends on the number of boxes. Since the total weight depends on the number of boxes, the independent variable, which is going to be our x variable, is going to be the number of boxes. We can have as many number of boxes as we want. The weight will change each time we change the number of boxes. That means that the dependent variable, which is going to be our y variable, this one is going to be the weight, and we are measuring the weight in pounds. The weight in pounds is the dependent variable. Okay, why do we need to know which is which? Well, because we need to write the two quantities as ordered pairs for our graph. Remember that an ordered pair is always set up as x comma y. All right, so if we go back to our table, okay, we just said that the number of boxes was our independent variable, which was x. So I'm going to put an x in my table next to the number of boxes. And then the total weight was the dependent variable, which was y. So next to the total weight, I'm going to put a y. Okay. I'm now going to take these numbers from the table and create ordered pairs that look like x comma y. All right. So from my table, my first set of data is going to be 0 comma 0. All right. 0 boxes had 0 weight. My next point from the table, my x value is 2, my y value is 4. 2 comma 4, 2 pounds, excuse me, 2 boxes weigh 4 pounds. My next point is going to be 4 comma 8, x is 4, y is 8. My next point, x is 6 and y is 12. 6 boxes weigh 12 pounds. And my last point is going to be 8 comma 16. When x is 8, the y value was 16. Okay? I'm going to take these points now, and I'm going to graph them at the bottom of the page. Okay, now before I can graph anything down here, there are a couple of things that we need to do. First of all, remember it's a proportional relationship between the total weight and the number of boxes. All right, knowing that it's proportional will help us investigate the qualities of a graph that show a proportional relationship. Before we graph, two things we have to do. First, number one, title and label the axes. All right. This graph is zoomed in on quadrant number 1. Okay. So this line that we see going vertically right here, this is your y-axis. We're going to label it with a y. This line going horizontally is your x-axis. So we'll put an x right there. Okay. We've labeled the axes. Now we need to title them. Okay, well, your x-axis, remember, x was your independent variable, which was your number of boxes. So I'm going to title this as the number of boxes. Okay, the y-axis right here, remember y was your dependent variable, and that was your weight in pounds. So we're going to label this now as the weight, and in parentheses, we'll put pounds so we know how we are measuring the weight. Very good, there it is. Okay, so we have titled and labeled each axis. The second thing we need to do is choose an appropriate scale for each axis. Okay, by appropriate scale, I mean I want to try to use up as much of this graph as possible so that I can easily read and interpret my graph. Okay, where the x and the y-axis meet, this point right here is the origin, and I know the origin is at 0, 0. So I'm going to put a 0 on the x and a 0 on the y. Now I need to come up with a scale for each line on my number of boxes. If I go back up and look at my table, the highest number of boxes in this row was 8 boxes. So I need to come down here and choose a good scale so that I would be able to show up to 8 boxes. All right, if I count by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would easily allow me to get up to 8 boxes. So let's go ahead and use that scale. So here's 0, there's 1, so this line would be 2. Here's 3, so this line would be 4, 5, 6, 7, 8, 9, 10. Okay, so I did a little skip counting. You can label every line if you want, but you don't need to as long as I can interpret easily what you're counting by. Okay, for the weight in pounds, again, I'm going to go back up and look at my table. The highest weight in pounds in this row was 16 pounds. So I have to be able to go from 0 pounds all the way up to 16 pounds. If I count by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm not going to make it up to 16 pounds. Okay, but let's count by 2. 2 pounds should be able to get me there. So that line would be 2 pounds. This line would be 4 pounds. 6, 8, 10, 12, 14, 16, 18, 20 would be up there at the top. All right. Now that our graph has been set up, we are going to go ahead and plot the 5 points from earlier. Our first point was at 0, 0, which is right here at the origin. So I put a little dot there at the origin. My next point was at 2, 4. So from the origin, I'm going to go right 2 and then up to 4. There's my next point. My third point is 4, 8. So I'm going to move right 4 and then up to 8, which is right here. My next point is at 6, 12. So I'm going to move right 6 and then up to 12 right here at this point. And my last point is at 8, 16. So I move from the origin right 8 and then up to 16, which is at this point right here. Now that I have my points plotted, I'm going to use a ruler and I'm going to connect those points. Okay. When I connect with a ruler, I have to connect from my top point all the way down to the y-axis. So I set up my ruler. Okay, there's my top point, and it extends to the y-axis here. All right, and I'm going to actually connect through that bottom point or through that top point, I should say. I'm going to extend out here as far as I can. And there's my line. And then to complete my graph, this line, if my paper was big enough, would keep going. So I'm going to put an arrow at the end of my line to indicate that the data would keep going. Okay, and this is a completed graph. So we just completed our graph. We plotted our points, we connected with a ruler, we put an arrow at the end, and now we need to interpret the graph. Okay, so right here it says, what are you noticing about the points when you connect them? When I connected my points with my ruler, notice that my picture shows it's a nice straight line. Okay, so one thing that I noticed right here, number one, I have a straight line. All right, I see a straight line. And one other thing that I notice is that my straight line, when I extend it back to the y-axis, it actually begins right here at the origin. So the other thing that I notice is that my straight line passes through the origin. Okay, these are two qualities of all proportional relationships. Remember earlier we said that this was a proportional relationship. This is what the graph of a proportional relationship will always look like. It will be a straight line and it will always pass through the origin. If you see a picture of a graph that shows a straight line and it's passing through the origin, then you know that the relationship is proportional. If the line isn't straight, or if it doesn't start at the origin, or both of those, then the relationship would be called non-proportional. Okay, but since this is a straight line passing through the origin, I know that the relationship is proportional. Fill in the point from the graph, 1 comma blank. Well, remember, this is your x coordinate, and we're looking for the y coordinate. So we're going to go to 1 on the x-axis. Here's our x-axis. There's 0, there's 1. If I go up until I hit the line, I hit right here, and now I'll come over here to figure out what the y value is. That's halfway between 0 and 4, which is at 2. So the point here is 1 comma 2. What does this missing value represent? Well, this missing value here, this is your unit rate and your constant of proportionality. Okay, 1 comma 2 shows the unit rate of 2 pounds per box. Okay, that's what we learned before. The weight was 2 pounds per one box, 2 pounds per box. And it shows that K equals 2 over 1, or 2. Okay, remember what we said back up here when we were looking at the relationship from the table. K had a value of 2, or 2 over 1. We also said last class that the way that you calculate K equals y over x. So in this example, your y value is 2 and your x value is 1, meaning that the coordinate would be x1, y2, 1 comma 2 represents that constant of proportionality. Okay, so from your graph, in order to get K, the constant of proportionality, you will always go to 1 on the x value, then move up till you hit the line to figure out what the y value would be. So in example number 1, we learned about a proportional relationship on a graph. A graph shows that two quantities have a proportional relationship if, number 1, the points form a straight line, and 2, the line goes through the origin, which is at 0, 0. The constant of proportionality K is always found at the point 1 comma K. Remember, you always need to go to 1 on the x-axis and then go up till you hit the line to figure out what that K value is going to be. Okay, so let's try this again here in example number 2. They tell us that the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. 6 feet per minute. Complete the table below. All right, so in 0 minutes, The distance is 0 feet. The sloth hasn't gone anywhere. In 1 minute, the sloth has moved 6 feet because it goes 6 feet every minute. That means that in 2 minutes, the sloth goes 12 feet. 3 minutes, it would go 18 feet. And in 4 minutes, it would go 24 feet. We need to now take this data and create ordered pairs. And remember, they're x comma y. Before I make the ordered pairs, though, I have to ask myself which is the independent variable x and which of these is the dependent variable y. Does the time depend upon the distance, or does the distance depend upon the time? Well, in this example, these distances were dependent upon how many minutes that the sloth had been traveling. Okay, so the distance in feet depends upon how long in minutes the sloth has been traveling. That means that the independent variable, this is going to be your time in minutes. Okay, your sloth can travel as many minutes as it wants. The distance will travel, or the distance traveled, though, will change each time the number of minutes changes. So that means the dependent variable is going to be the distance in feet. Distance in feet. Okay, so on my table, my time is my x, my distance is my y. Using this information, now let's set up our ordered pairs x comma y. So the first one, x is 0, y is 0. 0, 0 is the first point. The next point, x is 1, y is 6, 1 comma 6. Then x is 2, y is 12, 2 comma 12. Next one, x is 3, y is 18, 3 comma 18. And the last one, x is 4, y is 24, 4 comma 24. These are the 5 points that I am going to put on this graph down here. Remember, though, that before I can graph anything, I have to first label and title the axes. So let's do that. Vertically, this line here is your y-axis. Horizontally, this is your x-axis. The x-axis, the independent variable was your time in minutes. So let's label that as time in minutes. Okay. Your y was the dependent distance in feet. So let's title that distance. And we're measuring that in feet. Good. Now, we also need to come up with a scale for each axis. Remember, here's the origin, 0 on the x, 0 on the y. If you look up above at your time in minutes, all right, here's your table. The highest time was 4 minutes. So from the origin, we can easily count by 1. Okay, we can easily count by 1 to get up to 4 minutes. So there's 1 minute, 2 minutes, 3 minutes, 4 minutes, 5, 6, 7, 8, 9, 10 minutes there. For your distance traveled in feet, the distance here, 24 is the highest number of feet that we need to get up to, 24 feet. So from the origin, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Counting by 1's not going to do it. So let's try counting by 2 again. So that's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and at the top would be 26. Good. So now that we have everything labeled and titled and we have an appropriate scale, let's go ahead and plot these 5 points. We're starting at 0, 0, the origin. Next is 1, 6, so we move right 1 and then up to 6, which is right here. 2 comma 12 from the origin, right 2 up to 12. 3 comma 18 to the right 3 up to 18, which is right here. Ooh, I just realized that I actually put that last point in the wrong spot. 2, 12 is right here. 8, 10, this is 12. I miscounted. 12, 14, 16, 18, 20. There we go. So that's 6, 8, 10, 12 should be right here. That's why you have to count carefully. All right, so let me get rid of that little point right there. That's not really there. That looks better. All right, so 3 is at 18, which is right here. Then I'm at 4 comma 24. To the right 4, up to 24, 20, 22, 24 would be right there. There we go. Now that we have everything plotted, we're going to go ahead and use our ruler and we're going to connect. Okay, so again, we use a straight edge, never freehand on your graph. Here's my lowest point, here's my highest point. I'm going to extend back to the y-axis, which hits right here. And I extend through my top point, and don't forget an arrow. Okay, and so there is our completed graph. Now that our graph is completed, let's answer a few questions. First of all, they want to know the graph shows a blank relationship between the distance and the time. Well, earlier we said that if we see a straight line that's passing through the origin, like we do here, then the graph represents a proportional relationship. So let's go ahead and write that in. This is a proportional relationship. How do you know? The graph shows a straight line passing through the origin. When you have a straight line passing through the origin, then you know that it's a graph of a proportional relationship. The follow-up here says, what are the coordinates of the constant of proportionality? Okay, so they want to know where is k. Well, remember, back up here in the table, they say that the constant of proportionality k is always found at the point 1 comma k. So we need to go to 1 on the x-axis. So let's come back down here, find 1 on the x-axis, which is right here. Here's 1. We go up until we hit the line, which is at this point here, and then we come over, and that's halfway in between 4 and 8, which is at 6. So the coordinates of the constant of proportionality are 1 comma 6. Okay, this means that k equals 6, or 6 over 1, and it means that the unit rate is 6 feet per 1 minute. 6 feet per minute. In example 3, we have a completed graph already, and it shows the calories in snack packs. 3a says, determine whether the number of calories is proportional to the number of snack packs. And we're going to explain our reasoning. Well, if I look at this graph, I see that I have a straight line, and right here, it's passing through the origin. So I would say that the relationship is proportional. And the reason why is just what I had said before, because the graph shows a straight line passing through the origin. Straight line passing through the origin. Okay. All right, so since I know it's proportional, I know that there is a unit rate and I know that there is a constant of proportionality. Remember, to find that constant of proportionality, you have to go to 1 on the x-axis. So the coordinates are going to be 1 comma something. Let's find that. So here's 1 on the x-axis, 1 snack pack. We go up until we hit the line, which is right here. And then we come over and notice it's a little bit above the 100. Okay, it's actually 1 line above the 100. So I need to know how much each line is. Well, if I go from 0 to 100, that was 1, 2, 3, 4, 5 lines. That means that each line has to be 20. So the next line up is going to be 120. So the coordinate is 1 comma 120, which means that the constant of proportionality, k equals 120, or 120 over 1. So what does that number mean in this example? Well, for the unit rate, if we're looking at calories and snack packs, this k value means that it is 120 calories per snack pack. Okay, so you can always find the unit rate and the constant of proportionality from your graph if the relationship is proportional. In example 4, the cost of renting video games from Games Inc. is shown in the table. So we can see here the completed table. The number of games, notice, is your x independent variable. The cost, y, is dependent upon how many games that you order. So here are the number of games and their cost. Let's list the ordered pairs first. Remember, it's always x comma y. Okay, so my first x is 1 and the y is 3, so it's 1 comma 3. The next is going to be 2 comma 5. The next is going to be 3 comma 7. And my last x is 4 and y is 9 at that point. Okay, so these are the 4 points that we need to plot on this graph here. Let's label and title the axes. There's y, there's x. X for the title right here is the number of games. So let's put that down here, number of games. For y, they tell us that is the cost in dollars. So that's what we'll title over here, cost in dollars. And now I need to come up with a scale. For my number of games, x, my highest number is 4. So down here, here's our origin at 0, 0. Along the x-axis for the number of games, we're going to count by 1. 1, 2, 3, 4, 5. Cost in dollars, the highest number is 9. If I count up from the origin, I should be able to count by 1. So there's $1, 2, 3, 4, 5, 6, 7, 8, 9, $10 up there. Now we'll plot our points starting at 1 comma 3. Move right 1 up to 3. The next one's 2, 5, so right 2 up to 5. The next one's 3, 7, so right 3 and then up 7. And the last one is 4, 9, right 4, up 9. And there we have it. Let's get our ruler and connect our points. Okay, so there's my top point. There's my bottom point. Remember, I have to extend through the bottom point until I connect to the y-axis. And that happens right there. And I also need to extend through my top point and then put an arrow at the end. There it is. That data would continue forever. Okay, so here is our graph. And C says, does the graph show a proportional relationship? Well, remember, we need 2 things. We need a straight line, and if I look at the graph here, that definitely looks like a straight line. The other thing that I need is that it has to pass through the origin, and when I come to the end of my line, it hits right here, but the origin's down here. So this is not passing through the origin, therefore this is not proportional. This is a non-proportional relationship because the line does not pass through the origin. Okay, the line does not pass through the origin. In order to be proportional, both things have to be true, a straight line and passing through the origin. If even one of those is false, which in this case it's not passing through the origin, we know that it would be a non-proportional relationship. So at the bottom it says state the unit rate and the constant of proportionality. Well, since the relationship is non-proportional, there isn't a unit rate, so I'm just going to write n/a. It's not applicable. And if there's no unit rate, there is no constant of proportionality. So I'm also going to write n/a. So if it's a non-proportional relationship, no unit rate, no constant of proportionality. If it is a proportional relationship, you'll see a straight line passing through the origin. And you'll always find the value of k by first going to 1 on the x-axis and then moving up until you hit the line to figure out the corresponding y value.